So my name is Pablo Baquero. I'm presenting with Daoming, Lu, and Florian Rist. I belong to a research group that is dealing with design computation, fabrication, and that also belongs to the Visual Computer Center in Abdullah University, Saudi Arabia. Basically, what I'm going to talk today is about simulation and fabrication of deployable elastic stripes structures. Basically, this research started by finding the double curvature of Gaussian curvature of some surfaces where it is always complicated to find out how to deploy and deploy structures in order to have a double curvature negative surfaces. Most of the time, the applications of these kinetic structures for architecture are kinetic pavilions, temporary structures, retractable roofs. The advantages is that you can always make it by components in the factory and later deploy them on site. And it's also much simpler to join the stripes in a flat arrangement and to put them together dimensionally. For this, I have constructed this 3D printed flat element that later has become a negative double curvature surface. And for this also we follow a type of process that is based off the essential phase of design. It's always challenging the essential phase of design, which believes that design simulation reuse the data and test the physical model, where kinetic methodologies of design framework would naturally transition from a state of design fabrication simulation workflow into a design simulation fabrication, with everything is always fitting back together. and for this matter, it's always being designed in a flat state and later deployed, like is shown here in the black stripes that they were deployed in a more double curvature state, and in the blue line it's a local stripe that actually will help to sustain the opening structure of the deployment pavilion or structure that we are double curvature structure that we are designing. Basically, we try to also have a workflow in which we are rotating and changing the double curvature vectors of the normals of the surface, and we keep testing with the simulation. So basically, what we do here is that we test the way that the surfaces is being deployed, and at the same time, how is it constructed? So we keep changing back and forth the simulation state. For this manner, also we have tested it physically and also with simulation in the right side. This is just a set of continuous stripes that they are deployed, and once they are deployed, they have a double curvature state. Basically, this is a negative Gaussian curvature. Also, this can be applied for different connections of set of stripes that later they have one singularity, like in this example that we see here, that we have three set of stripes with one singularity, or here that we have the same idea of connecting four set of stripes with two singularities. Also, incorporating this workflow, it helps to optimize the geometry, the stripes, and the great benefit of this is the the material distortion of the deployment state. That also additionally this can be manufactured to be reduced on site, and assemble time is reduced to be able to construct it on site. Later, this research has been enhanced in a metallic structure that has been previously simulated and later constructed with a connection mechanism that is not really very well still underdeveloped. But the idea is to be able to construct flat stripes and later to deploy them on site. And this is the final double curvature project that we have been constructed with 16 different stripes and assembled later with one single set of stripes. And there is a edge stripe that it keeps all of the stripes open. And basically, this is the bibliography, and that's what I wanted to present. Thank you so much for your attention.